Design of IoT data acquisition system based on neural network combined with STM32 microcontroller. Aiming at the low efficiency and high power consumption of data acquisition in the Internet of Things, a data acquisition system based on the combination of neural network and STM32 microcontroller is designed. In the control module, according to the system functional design and performance requirements, this minimum system module is used at the control core of the system. The data acquisition terminal adopts a baseplate plus core board structure and is composed of high-speed data acquisition module. And this platform and various expansion function modules. 8 types of environmental data sensor modules are used to build sensor modules. The K-means convolution neural network is used to realize the data classification of the Internet of Things, and the design of the data classification module is completed. The performance of the system is tested. The test results show that the system can realize the real-time collection of indoor environmental data. The communication rate is higher than 80 Mbps, and the power consumption of the data acquisition terminal is low. Introduction. In recent years, the rapid development of the Internet of Things industry has become the strategic commanding point of a new round of economic and technological development in the world. And there are traditional electrical appliance manufacturers, as well as some internet companies and startup companies. The second is the control center, such as Ali Xiaozhi, launched by Alibaba, which integrates many apps. The third is ecosystem. The main model currently emerging is intelligent module plus control center plus cloud service, such as Xiaomi, Haier, Ali, Tencent, Baidu, etc. The fourth is the operating system. Currently, Ali YamOS, Tencent's TOS, etc. are promoted to the Internet of Things operating system. The driving role of the Internet of Things is manufacturing, operation, application, and other related industrial chains is becoming more and more prominent. At the same time, with the further upgrading and improvement of the Internet of Things industry standards, the Internet of Things will extend in the direction of clustering and collaboration, further strengthen industrial cooperation, and accelerate the penetration and integration of the Internet of Things in related industries and fields. Further build an independent innovation system, enhance the core competitiveness of the industry, at the same time give full play to the market advantages, cultivate and expand the Internet of Things industry, and form an all-round integrated global Internet of Things architecture system. And at present, the widespread popularity of the Internet of Things has been integrated into all aspects of people's daily production and life. From the perspective of structural layering, the Internet of Things can be expressed as a three-layer architecture consisting of a perception layer for comprehensive perception, a network layer for reliable transmission, and an application layer for intelligent processing. Also, under the above background, this paper proposes the design of IoT data acquisition system based on neural network combined with STM32 microcontroller. The K-means convolution neural network is used to realize the data classification of the Internet of Things, and the design of the data classification module is completed. First part is about IoT data acquisition system design, the control module design. In the control module, according to the system function design and performance requirements, this minimum system module is used as the control core of the system. It's mainly composed of this single chip, microcomputer, clock circuit, reset circuit, power supply, and etc. With the peripheral design circuit of the system, the information collected by the sensor is converted into information that can be identified and processed by itself. And the main features of this series of microcontrollers are shown in this table. And second part is the design of data acquisition terminal. The data acquisition terminal adopts a structure of base plate plus cloud board, which can maximize the scalability and versatility of the system. It is mainly composed of high-speed data acquisition module about this platform and various expansion function modules according to different application scenarios. The backplane, sensor, and the USB device can be replaced, which reduce the project development cycle and has strong flexibility. The high-speed data acquisition module is composed of high-performance sampling chips and FPGA chips, which are responsible for high-speed data acquisition. And the data processing part controls each I/O part, communication module, storage module, and video monitoring module of the terminal to meet the needs of terminal expansion functions. The system frame of the terminal data processing part is shown in this figure. Digital signal interface. The system can communicate with any sensor with an RS485 interface, or read external environmental data to the system through a general purpose GPIO port. Communication module. The user can view the collection data in real time remotely or locally through the wired Ethernet port, 4G modem, and wireless Wi-Fi interface. It's also convenient for users to transmit the collect data to the data management center in a wide wireless manner. And video surveillance module, real-time display of external environmental conditions through a USB camera. Data storage module, realize the local cache of data, supports storage in mobile device or flash. This is the data included, the module included, the sensor module design, and the nerve endings of the Internet of Things. Sensors are important element for human beings to fully perceive the natural world. The wide-scale application of various sensors is a necessary basic condition for the Internet of Things. Sensors can be divided into humidity sensors, magnetic sensors, gas sensors, chemical sensors, and so on. This is according to their applications. And the range data of the 8 types of environmental data sensor module we mentioned above are shown in this table. The environmental data sensors perform their respective duties and monitor the corresponding environmental values in the surrounding environment. Due to various data formats, units, value ranges, it collects. It needs a command to manage it, resulting in a sync node, that is, a coordination and management node. According to the derived purpose, the coordination management node mainly aggregates the data of 8 environmental data sensors, formats it, and transmits data with a TQ6410 gateway. The sync node used is STM32 W108. And finally, as the system test, indoor environment data collection. The performance of the design IoT data acquisition system based on neural network combined with STM32 microcontroller is tested. Use the system to collect indoor environmental data. The indicators collected mainly include three aspects: safety indicators, comfort indicators, and health indicators. Among them, the safety indicators focus on remote video monitoring of the indoor environment to know the status of the home. The comfort index is to monitor the indoor temperature, humidity, and the other indicators to make the indoor environment a comfortable environment. Health indicators are monitor indoor inhalable particles and some harmful gases. When the concentration of inhalable particles or harmful gases in the room exceeds the preset threshold, it can alarm in real time. This part is mainly to test the data acquisition and data processing capabilities of the system. Due to limitation of the laboratory sensor conditions, the test process takes the testing of temperature, humidity, smoke, carbon monoxide, and carbon dioxide as examples to verify the data acquisition capabilities of the system and the data acquisition terminal. The function of wireless access to the IoT cloud platform. The test hardware consists of the following: voltage regulator source, data acquisition terminal, video camera, signal source, host computer, DS1-8B20 digital temperature sensor module, DHT11 digital temperature and humidity sensor module, MQ2 smoke sensor module, MQ7 carbon monoxide sensor module, and MG811 carbon dioxide sensor module composition. For the test of the data acquisition function, the signal source is used to simulate the high-speed signal, and it is connected to the data acquisition terminal. In the IoT cloud platform, adding data acquisition terminals and sensor devices, the cloud platform can display the data of remote networked data acquisition terminals in real time. The IoT cloud platform can view the data collected by the terminal in real time and perform operations such as analysis and supervision. The collected data can be drawn into a curve, a pie chart, or a bar chart. In the experiment, the front-end sensor constantly senses the external data, and the data collection terminal reports the data to the cloud platform every 5 seconds, corresponding to each node in the chart. Conclusion: the data acquisition system of the Internet of Things is the layer closest to the perception of the surrounding environment in the Internet of Things layer. It is also the tentacle of the Internet of Things and the most important part of the Internet of Things. In the research, through the experimental verification, the designed data acquisition system of the Internet of Things can realize the real-time collection of indoor environmental data. The power consumption of the data acquisition terminal is low, and the system communication rate is stable. However, the designed system still has some shortcomings. For example, the system cannot realize the simultaneous collection of multiple Internet of Things at the same time. In the future, some expansion and improvement can be made on this basis.